Hello, everyone. My name is Chinmay, and I'm a part of the Complex Fluids and Multiphase Flow Lab. Our lab is under Professor Cari Dutcher, who is the faculty in the Mechanical Engineering Department here at the University of Minnesota. Our group's research interests are in the fundamental studies of the dynamics of complex fluids and multiphase flows, aerosols, and emulsions with a specific focus on environmental remediations. Students from all areas of engineering and science are welcome here. With that, I will go through an overview of the different projects currently ongoing in our lab. The first subcategory of projects that we work in this lab deal with coalescence and thin film dynamics. This consists of several projects, including that of droplet coalescence, bilayer thin film dynamics, and dynamic surface tension. We also work on multiphase transitions, islet characterization, agricultural sprays, and Taylor-Couette flows. Microfluidics is often used as a tool in most of these projects. The first project that I want to talk about is that of droplet coalescence. This has several applications in bilge water emulsions and firefighting foams. In this project, we have two microfluidic devices. One is the untrapped microfluidic device where two droplets are brought in contact with each other and allowed to coalesce in a Stokes trap. The second is a device in which one of the droplets is in contact with a PDMS wall and they are brought in contact with each other to coalesce. As you can see in this plot here, the non-dimensional film drainage time for that of the trapped droplets is lower than that of the untrapped droplets. This shows that when you introduce a heterogeneity in the coalescence process, it helps in decreasing the thin film drainage time. To further investigate the factors that affect the thin film drainage, we use a numerical model of the bilayer thin film dynamics. We use a coupled evolution equation to describing the perturbation of interfaces and surfactant concentration. This enables us to study how surfactants affect the stability as well as rupture of the film. It is also important to characterize the surface tension at an interface, particularly at a micro and macro scale. Microfluidic device, as shown here with a narrowing channel, is used to measure the surface tension. The narrowing channel alters the droplet shape, and by measuring the changes in the shape, we can measure the surface tension. Comparison to that of traditional methods like droplet pendant drop is also done, and it can be shown that the time scales for the equilibrium surface tension for the micro device is much smaller than that of the macro device. We also use a multi-well microfluidic device, as shown here, to study the phase transition of a solution. The well shown here traps the droplet and they evaporate over time through the PDMS walls. The droplet consists of several organic as well as inorganic components that form crystals, as shown here. Weighting the components of the solution results in different crystal formation. This study enables us to develop a better climate model for weather predictions. We study the osmotic response of pancreatic islets using a different microfluidic device as shown here. The osmotic response of islets is important to characterize for cryopreservation and eventual transplant in clinical scenarios. The volume changes of islets, as shown here, is measured when surrounded by different chemicals. This allows us to improve islet cryopreservation strategies. We also study the different factors to optimize the droplet sizes of agricultural sprays. For this, we use a wind tunnel to measure the droplet size. We also use different imaging techniques to study the uptake and evaporation on a leaf surface. To determine the formation and stability of bilge water emulsions, a Taylor-Couette cell is used. It consists of two concentric rotating cylinders and is ideal for mixing dynamics and stability of emulsions. We also plan to use this setup to study the flocculation of microfluidics. With that, I want to thank all our sponsors and I invite you to check out our website.